Three thin metal rods of lengths 9, 12, and 15 are welded together to form a right-angled triangle, which is held in a horizontal position. A solid sphere of radius 5 rests in the triangle so that it is tangent to each of the three sides. Assuming that the thickness of the rods can be neglected, how high above the plane of the triangle is the top of the sphere? So first thing we've got is these rods, right? They're fused together to form some sort of a triangle like that. And the good news is that they tell you that it is a right angle. So let's make that the right angle. And then they place a sphere inside. So I'm going to try to draw that. So here you have a sphere, and around it is a right triangle, and I hope you can visualize this. It's kind of difficult, I know, but what I've done is I've drawn it in a way so that these solid red lines represent the triangle that you can see, and then the thinner red lines are what you shouldn't be able to see. It's on the other side of the sphere, and at some point we have this intersection. And now what they are saying is that they are telling us that the radius of the big sphere is 5, and somewhere in this sphere there is going to be a point that, if you look at it from a perspective of a horizontal plane, it's going to cut the sphere, all right? And from that point to the top, very top, they want you to know what is the distance. So let's say it cuts it, it's hard for me to draw, but let's say it cuts it here. They want you to figure out the distance from the very top till that point. All right? So I hope that makes sense. Now the very first thing I have to do is make that cut, that cross section. Picture it like this is a, I don't know, a chocolate ball, something that you can cut, and you're slicing it. You're slicing it exactly right there where that line is. And I'm going to now look at that cross section. And that diagram represents the cross section. So I really want you to understand the question before I move forward. You've got this sphere, right? And somewhere they have sliced this sphere about here, basically, that area right there. It's obviously below the center of the sphere, because if you chopped it at the center, then it would basically become half of a sphere, and that's not what we have. We have it a chop that is basically, or slice below the center. You understand? And then therefore, when you create this cross section, this blue section here is basically looking at it from the bird's eye view of the sphere once you've sliced it. All right? So now what I'm going to do is I'm going to label the center to the tangent lines like that. From there to there, from there to there, and from here to here. All right? Now these represent the radius of that blue circle, right? Now, please remember that this radius is not the radius of the sphere. It is just the radius of that blue circle. And that blue circle is just a cross-sectional area of that slice. Okay? So now we need to draw a few more lines, and I will then start explaining this. The next few lines are basically from the center of the circle to the edges of the vertices of the triangle, like that. Okay? And then we start labeling what they gave us, the side lengths of that right triangle. 9, 12, and 15. Okay? And 9 squared plus 12 squared is equal to 15 squared, so that's why we know for a fact that it's a right triangle. Now, the full area of this triangle, since this is a right triangle, is going to be 1/2 9 times 12, correct? 1/2 base times height, basically. And also, if you look at this diagram, if you were to add up these guys, 3 triangles, if you add them up, it would equal the full area. So the 3 triangles are this one here, right? That's the first one. Then you add it to this guy, and then you add it to the bottom one, this one right here. If you add up those 3 triangles, it should be the same. And we can do that because we have length, we have the height of all of those. So for example, for the first one, which is right here, it's basically 1/2 base times height. The base is 9 and the height is r, correct? And then similarly for this guy here, length and height of that triangle, 1/2 base is 15 and the height is r. And finally, in that triangle, we have the base and the height. 1/2 base is 12 and the height again is r. So we can do this now. 12 divided by 2 is 6. 6 times 9 is 54. Like that. This becomes 9 over 2r plus 15 over 2r plus 6r. So this becomes 24 over 2, which is 12r plus 6r, so 18r. And therefore r is equal to 3. So this r is 3. And I hope now you know that it's not the radius of the sphere, because the radius of the sphere is 5, correct? All right. Now let's start talking about what is it that they want us to figure out. This point right here is basically where the slice happened, okay? So somewhere. It's a 3D diagram, so I know it's a little bit hard to visualize, but just be convinced of that the slice happens here. All right? And they want you to figure out how high above the plane of the triangle is where the slice happens, is the top of the sphere. So basically from this plane all the way to the top, what is that height? So we'll label it something. Let's call it h. Okay? Like that. Now I'm going to draw it again because I really want you to be convinced of what is happening in this question. I want you to really understand it. So here we go. There's that cross section again. And there's your blue circle that represents the cross-sectional area. And we calculated this r right here is 3, correct? And then now we want to figure out the distance from the plane, which is right here, all the way to the top of the sphere, which is right there. Now we know that as we get up to there, there's going to be a radius, correct? There's going to be a radius. So I've drawn that in. Radius of what? Radius of the sphere, which is 5. And then this C that I drew represents the center of the sphere. And then from the center of the sphere down to the bottom, or down to the plane, is this distance right there. All right? And that distance I can call h. And that's pretty much it. And now I'm going to draw one final line, and that is a line from C to the edge right there, like that. And that line that I drew, because it's from the center of the sphere to a point on the edge of the sphere, that represents the radius. All right? And this in here is a right angle right there. So, without getting too messy, we can always redraw this to make it a bit clearer. This triangle that I drew in there, right there, like this. Okay? So what do we have here? We've got, this is a right angle. This is 3, this is h, this is the center point, and this is the radius. All right? And we can use Pythagoras. 3 squared plus h squared is equal to r squared. And therefore h squared is equal to, r is 5, so 5 squared minus 3 squared. 25 minus 9 is 16, and therefore h is equal to 4. So h is 4. And we're done. We want to know the distance from the plane of this triangle, which is right here, all the way to the top. Well, from here to here is 4. From here to here, the center to the top is 5. So therefore, the total distance is 4 plus 5, which is 9. The top of the sphere is 9 units above the plane of the triangle.